Hello everybody and welcome to my video. I'm going to take a kind of side path here for a little bit and talk about some IP address automation. IP address automation, of course, means different things to different companies. It means different things to different processes. And as you're evolving and you're working within your various networking, your IP addresses, your devices that use those IP addresses, the services that hand out and resolve names, and all of that process, as you're working through your daily tasks, you're going to have different processes, different people, different applications potentially, and sometimes this can get very convoluted as you start working through really what does automation mean. Now, if you go out and talk to any network engineers, and I kind of come from this perspective from an old time ago at Georgia Pacific, but at one point, you're going to have to look at how you get those IP addresses to begin with. And it's not that the network exists with IP routable capabilities first. It's that somebody had an idea to assign an IP address, give it a network, give it a route, and that route connected multiple points, and the points ended up in the internal network or up into your internet. So all along the way, those IP addresses had to be established. So that's kind of, I don't want to, preach to the choir or anybody here, but when we think about that process, IP address management fits within a very niche point of this. And if you're documenting your IP addresses properly, you then know what your networks are, your subnets, you know what the next available capabilities are. And then with IP control, we interface with these IP addresses through APIs or through the web UI or whatever your preference is. So I want to kind of talk about that and kind of talk about some things. And I've kind of learned in my examples, I guess maybe here in the next 10, 15 minutes to kind of go over what I've done and see what you can do in terms of how your network is laid out and how you might want to structure it. Because I think at the end of the day, as I want to do as well, hence these videos, I want to help instruct as many people as I can with the same hours that I can put in every day. And if 1,000 people can watch a video, I can help express the way things work better that way. So we want to reuse things to the best of our abilities to help us along in our day-to-day things, and that we can focus on the priorities in our lives that come and change every day. So again, preaching to the choir, so here we are. So one of the things I learned along the way is IP address management to some companies means they deploy sites. Now, as ambiguous as IP address management is to some people, so are sites. But in the terms of IP control, we kind of give you some visual keys or cues to help you determine a site, and we do that through our container mechanism. So to begin with, a site to us isn't necessarily a container. A site is the network blocks or subnet blocks and the template, or we'll say the pre-defaults of what that site should have. And if you're working in the WAN environment or MPLS or in anything around this world, you typically are going to have standard site allocations. And effectively what you might have then is you're going to have classifications that you'll have a small site, you'll have a mid-size, a network, a campus. You're going to have all these different types of definitions. The one thing that's going to be consistent, though, we hope, and you hope, is that within a site, you can have some consistency that it can be templated. And the best example of this might be branches within a financial institute that has cookie cutter type environments, or fast food, restaurants, retail, etc., where they have a template. And they have that template because it helps them deploy whatever it is they construct in a very efficient, reproducible way that they can hand a document to somebody and they can go do it following this process. And that's how it is. And then they keep their, of course, key people to help them because they know that they can do it quickly and learn the capabilities. Same thing here. So let's go into the subnets. And here, what IP control is going to help represent is how your subnets, and this is the key thing, your subnets for a site, what size and what types, and are there any kind of other informational keys like user-defined fields or allocations that you would want within those sites. So as an example, we have the data subnet. And for every small site, let's take it a branch, there's a data subnet, a deploy 24, and then you're going to have other things for management and wireless and others. So if we look at the data subnet, which is a block type we've created along the way, we have the ability to set the version, v4, v6, same syntax context, and then you can select your sizes. Of course, if I were working within a very lockdown process, I would only have one choice if this were a branch, and I would say it would be /24 for this user. That would be the only choice, as an example, at that size, or maybe I would have different types of selectable capabilities. So we have a 24, and then here what we're telling it is we want to use the best fit algorithm so that it'll take the next available block that matches the 24 as free that we can assign without conflict. So we do not allow for overlapping blocks in terms of duplicates within the same container hierarchy, and I'll get to that in some of these videos. So here, when we do this, we have this template capability, and there are key fields, and I believe these are listed here when we get down into the block name. And what it does is it helps you by using a construct of percent signs using key fields to help you construct a dynamic name. So if you see this on the screen, this is not an error. This is actually planned and in this format for a reason. So we're going to tell it then that the start address of this block that we allocate / block size is what we want the name to be. And that's actually the default by the way, but we could construct this with anything else. So we could actually prepend it with container name. So as you're automating your systems, you may have a container name structure that might represent data centers, function features like servers, printers, prod, dev, etc. And those can be prepended or appended to the containers as that name appended to the name of the subnet as you kind of look through this process. So don't worry when you see that. That is a normal process. You can also override that when you're applying the template. And then, of course, you're going to give it a status. The thing about the sites is, and you might want to have different templates built that help you to identify your regional deployments. Maybe if you're doing this at a region where you're going to aggregate, meaning I'm going to take from a larger network a smaller piece, and I'm going to provision it down to a site, and that site's going to later use it for other aggregates or subnets. Right? So carving up that range of addresses. So we can make that aggregate a subnet reserved or other status. Okay. Primary subnet and non-broad, well, primary subnet's really intended for some DHCP functionality, and I believe this is used for Cisco CNR. The non-broadcast actually expands that subnet outside of its usable addresses and includes the subnet address 0 and the broadcast address. So if you're a service provider, you might have /31s you need to use, and this is a way to expose that address. We're not going to create DNS domains, but just as you know, and again, if you're doing multi-tenancy and you're associating a DNS domain of the subnet size, you can actually create it at this time as the subnet provision for the site. So there are some few things there you can provision. And then I have, just for this data network, a couple of allocation templates even, that for the subnet 24 private, I have an address pool from 50 to 99 and an address pool of 100 to 250. So what I want to do here then is when I create this subnet, I want it to create these ranges of reserved and dynamic DHCP. These are going to be later used for other process. And in the policies, I can predetermine the subnet for or DNS server, the primary and secondary DNS and DHCP services. I can also set up any policies for those in terms of options that might be handed out to the client. So again, you might have a branch template standard that has a standard set of options, and those options are going to be applied to every subnet through this template. And then your forward DNS domains that you could have defined for the subnet and its host. So all of this information in terms of the subnet template will then be auto-populated. And the same with the management for the 30, the 29 for say firewalls, maybe some DMZ, maybe even internet egress if you have to do that at the branch level. Voice over IP if you're using those in wireless. So some custom functions here that we can look at with allocation templates. And then the key to this is when we go into a container, such as if I looked at P01 and selected add site to an existing container, I would see some things like small site, and this will show us that template. I can change these. I can look at the allocation templates. I can define the DHCP if I want to change it from other than the selected subnet, and I can do other things and then submit this in order to allocate the next available subnets for this process. And of course, any callouts that might instruct this in a later setting to feed to the network engineers to go out and build the site on the router. because now, from an IP address management standpoint, we're looking at getting this information into the routers that need to be then procured or acquired or installed to support the sites. So all of that cookie cutter stuff then kind of leads into a process, this being one, and where it fits within your process obviously is maybe post installation of the router, prior to routing configuration on the WAN connectivity with the IP. And you may have to do some things to put this in your workflow process. Right, so I wanted to just kind of touch on that. Now, in terms of templates and in terms of automation and how do you proceed with automation, kind of using these containers, there are some restrictions, there's some guidelines, there's some things that you need to be aware of, and then some that you can be a little bit more loosely aware of, so you don't have to be bound to the service or to the APIs. And so what I try to do, and when I deal with APIs specifically, as I try to duplicate everything as much as possible, I develop at least one site, one flow of the containers, the aggregation blocks, the IP addresses and subnets, and I make sure at least that one site works, and then I create a process that duplicates that whole thing. So when I start to begin to dealing with how do I deal with new sites, and within the site there might be other things like creating containers, setting up user-defined field templates, and some of those cookie cutter things that should be inherited just with the new subnet data. So that's where I have gotten into involving templates, where by using the templates, I can then set up like what type of user-defined fields are available at each of the different tier levels. So like at the region level template, I might have certain fields. At the state level template container, I might have different sets of fields or the same. And then down to the site, I can have other fields. But even more important to that is that each one of these template levels follows an IP address plan and an IP address automation procedure. In that, I have a IP address configuration plan for aggregation blocks. I always want them to be of a certain size, and I always want them to be in the region template container, which is a child of the root at each level here. Then I'm going to have beneath the region my state, and then beneath the state I'm going to have the site. So as in the Northeast is a region, I then have the aggregation blocks. If I deselect this check, you'll see that. And then I'm going to kind of follow this plan. Beneath the Northeast aggregation, I'm going to have the state aggregation. And under the state aggregation, it's only using the 19, whereas the region is going to be a 16. So you can kind of see how we're summarizing this now down into more of the state level at this level for each of the different block types. And we're also looking at the ranges of address space from a planning perspective, so that you as an engineer knows that as I'm starting to build out this process, happens every one of us, we start to build and grow, and we just find out we've cornered ourselves into an IP addressing scheme that we can no longer support as we evolve into new services, new routing capabilities, and so forth. And we find that we fragment address space and we just don't plan it accordingly because, well, there just traditionally, has not been very many good planning tools out there other than IP control. And so we've done this very well in terms of free space, in-use deployment space, and then helping the engineers plan this. So, and then following, just to keep going through this, I then have the subnet level. And at the subnet level, those policies I've set up and I, inherit as I look at, say, a branch or a, site, are only selecting the available types of blocks. It only selects them from their appropriate data types. It already sets the name and everything we need so we can kind of introduce the automation. Now, then when you take a look at this, you say, well, okay, what next? Well, when we take a look at the process and just to kind of follow this site capability, the site capability assumes, of course, your container exists. And that when you're in the site, because the site to us in this term is a group of blocks, maybe of consistent types, and that's what this is. So that allows you then to select a type like we did, the site, and then you could go ahead and apply that template. So kind of following this process, if I were to start a new region, a new angle, etc., I would start going in and I would go in and apply, add a site. I would then say this is going to be my region aggregate, which you see will select a 16, do a best fit, which is going to take the next available /16. So regardless of the sequence of this, if it's going to be a state, we're going to assume a summarization on 16, right? Or in the region, a summarization of 16. And then at the state level, if we need to do anything within a routing, we're /19 aggregation. So in that Northeast, you might have different aggregate route types coming off of it. And so here we are, and then down to the site. So in that's where the site is actually applied. Well, that's part of the process, and that's part of kind of where we want to be in the end. And in the end, I want to be able to say as an administrator, I want a site, and I want that site to basically be like the PA0001, right? So that's kind of what we wanted to do, and I want to create that site, and then I want to apply a small site subnet template to that site to create the subnets. And so to kind of demonstrate that, I want to show you real quick what I've got. I have a PowerShell module I've been working on, and taking all the APIs and kind of working around some of the function, and with the adds, the imports, the removes, and then of course having the ability to do multiple things within the scripting language to accomplish multiple tasks in a single process. And one of those I created was this add IPC site with the intent that I want to then start using my templates to clone. Okay, so hear that word, clone, which in the management of the container, you can clone these to duplicate a container. But based on where I want it to be defined within this template structure, I can then say grab, clone, PA001 because I want to add a new site into Pennsylvania. If I want to add a new site into Georgia, I might clone Atlanta 001 or Macon or Columbus, and so on and so forth. So based on where you want the new site to be, you would say, I want to clone it, whether PA or GA or down into the lower levels. And so I did that. And effectively what it does then is it goes out and it gets a container. It gets the container we're told to clone, which pulls back all of the attributes. We have all of the valid block types, all of the user-defined field types, the container information that's there. And effectively all I do then is remove the ID and return, change the name so that it now reflects my new container name, which you prompt, and then it builds the container. And then we'll lastly call the add site API, which will then create those subnets. So if I were a DevOps guy and someone came up and said, I need to add a site, well, here it is. I'm just going to run that command. It's built the site. It's PA002. And I can now see that the site's there. And then here are all the subnets. And if there's any DHCP scopes or reservations and so on and so forth, it's all done. All of that information then, of course, can be fed out to the callout manager, telling it to your router admins that here's the subnets, here are the networks. The IP addresses could have a call out as well. There could be a route of one of those, of a router type to, again, your network administrators. Here's your IP address for this router representing this site. And so from an automation and of an IP address automation, if I'm looking at this from a network perspective of a new site or planning, that's about as fast as I can get it. And that's what I want to have in terms of self-service. I want to have people that should do this, do that. And so there's one way to create a step. Set up a process. Maybe it's something you do through the web or your programmers can do to help you take just the minimal fields necessary to define a much larger task that gets automated for you through IPs. And really, when you're looking at IP address management, that's our key. That's our focus right there. And then as we start to work into other processes, we then involve DNS domains. If you're, say, a hosting provider, adding new domains and deleting them and importing records and things, same process, same principle. So pick and choose your IP address automation where you need it. If you're looking at IP address automation, well, of course, all this has to exist before that. So take it up one level to your network engineers. You guys use maybe this type of level automation for sites. But when you get down into your IP addresses, what about servers? What about VMs and spinning those up? Well, same type process here where you can go in and import an IP address, add an IP device or something, and then you can automate that, telling IP control to give you the next available IP address for a server that you can then use for the virtualization and set up DNS and pass all of its attributes in. And again, thinking from not that we're the overall orchestration or automation perspective, but that the IP address portion of that automation and how you obtain and store that data with us is going to help provide you this API auditing and capability inherently. So it might be a separate external process, but by far more capable, and the fact that you can integrate this into DNS, DHCP, have any number of administrators, and then have different tools and processes. This is really a great solution, and something you should look at when you think about, again, IP address automation. Right? Now, if you're a server admin, again, setting up and provisioning VMs, you probably have tools that go out and talk to Azure, that talk to your virtual VMware, things like that, OVI tools and stuff. So there are things already there, and getting your IP, typically people use DHCP. It's 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 an easy process to take advantage of, but it needs to be controlled, and DHCP is not the answer to everything. When you set up servers, then you're using dynamic addresses, and those addresses change if they do, or having to go in and reserve them over time. You're basically complicating the process a little, but then again, there's some savings with setting up DHCP versus setting up static. So you got to kind of measure those things too, and we have a lot of capabilities in terms of importing and automating IP device for static entries, but we can do the same for dynamic. We can do the same for reservations for DHCP. Instead of you having to go out and acquire a dynamic address from a perfectly good pool and then having to come back in and split it so that you can take your reservation, why not just reserve it up front, go ahead and get the MAC address as you start to spin it up and reserve it. So there might be some things here that might, help you automate it by doing it up front because you have the IP address tools that weren't there in other tools. So I'm ranting and raving now, so I just wanted to go through this because I've been doing this part of this for literally 23 years and working with, building my own access database tools in the past years, and having to deal with very large organizations and importing IPs and doing this automated. And I've been doing this for 23 years, not through APIs, but now with the APIs. There's so much capability you can do to then simplify life, simplify moving on to the task, and really so that we can focus back on what's important, the sites, the acquisitions, mergers, things we have to deal with every day as well. So thanks for bearing with me. Thanks for my rant. This is my opinion, of course, on what IP address management and that level of automation can turn into. And if you have any questions, feel free. I also have dealt with this and dealing with like self-service portals. And then thinking of things like how do you integrate the APIs to, build a custom process. So there's so many more things you can do with this that you can customize it just to your abilities and what your screens are. And even this here using Vue.js, JavaScript programming, and the way our APIs naturally fit with the JSON, of course. Setting it up so it's just as easy as saying, give me a VLAN ID and choose it from one of the available. And then setting up other APIs for, whatever your consistent parameters are. If you want to interface it with DNS and, those checks and balances, even whether that's available, of course, not getting into available IPs. So there's a number of things here and things you might want to look at in your process. But heck, this is what automation is. So if this level of it then is taking automation to a user input, whereas you might want to have, say, automatic provisioning maybe without user input. So at some level, there might even be some AI involved here that we'll want to look into. So again, sorry to rant again, but thanks for bearing with me, and I'll let me know if you have any questions, and we'll hopefully see you in another video. Take care.